Welcome back. In this chapter, we're going to be talking about probability, and before we can do any of that, we're going to need to start with a bunch of definitions. To begin with, we're going to be talking about experiments in this chapter. And when I use the word experiment, I'm not using it in the sort of chemistry or physics sense. I'm thinking about an experiment as any kind of an activity where we observe something. The observation might be a number, it might not be a number. Anything that we observe counts as an outcome for that experiment. So an example might be I'm going to select a card from a deck and observe what color it is. Or I might go to the mall and randomly select a person and ask them what they had for dinner last night. All of those things are experiments. And anytime I get an observation, that is an outcome for that experiment. If I were to take all the outcomes and group them all together, make a collection of all the outcomes, we call that the sample space. And we're going to use a letter S to denote the sample space. Kind of in the same way in chapter 3 we use the U to represent the universe. And it has a similar sort of meaning. So in chapter 3, the universe, that was all the things that we were interested in discussing or counting. Here, the sample space, this is the collection of all the outcomes for the experiment that we're discussing. So similar to the universe where we've got sets inside the universe that we might be interested in, set A, B, C, and so on. Similarly, in the sample space, we're also going to have sets within it. It's just now we're going to call them events. And similar to how we did our notation with sets, where we used capital letters for them, for events, we're also going to use capital letters. So before you might have had sets A, B, and C inside of a universe. Well, now we're going to have events A, B, and C inside of a sample space. And each one of those events has outcomes inside of it. Could have very few of them, could have all of them. So we're very loose in what we're calling an event. It's just any collection of outcomes. That would be an event. And when an event occurs, that happens when we observed one of the outcomes actually happening. So, for example, if my experiment is to select a card from a deck, and the event that I'm interested in is, did I select a heart, yes or no? Well, if I pull a card from the deck and it turns out to be a heart, then that event occurs. And if I pull a card from a deck and it's not a heart, then that event did not occur. So when we're talking about these events, we're interested in did they occur or not, or actually what we're really interested in for probability is how likely they are to occur or not. And that's what probability is. Probability is a way for us to measure how likely it is that we're going to see some event happen or not happen on a scale from 0 to 1. So for us, when we're talking about a probability of 0, that would be something that is impossible to occur, guaranteed to not happen. And then the highest possible probability we have is 1, and this would be for things that are guaranteed that they definitely will happen. And anything that might happen, so not impossible, not guaranteed, that'll have a probability somewhere between 0 and 1. The notation that we use is to put the P in brackets with the name that we've given to our event. So P of E, P in brackets E, that's the probability that our event E will occur. Okay, let's do an example. So for this one, it's not maybe the most exciting experiment in the world. We're just tossing a coin twice, and we are going to record the sequence of heads and tails that we might observe. So I'm going to list all of my outcomes. I'm going to use my counting skills though, because I know that if I'm thinking about how many possible outcomes there are for this experiment, I know that this is an experiment where there are two tasks. I'm going to flip a coin once and then I'm going to flip it again. And for each time that we have a flip, there are two options. So there's two options for the first flip. There's two options for the second flip. That means there should be 4 possible outcomes for this experiment. So I'm going to write down my sample space, my 4 possible outcomes. And I'm going to say that the outcomes are, we either have a heads followed by heads, or heads followed by tails, or tails followed by heads, or we have tails followed by tails. Those are the four outcomes for my experiment. Notice I'm using the same kind of notation that we did back in chapter 3. I'm using curly brackets to indicate that I've got basically a set. And that I list my items inside my curly brackets, and there we go. That's my sample space. Now I'm thinking about an event E. E is the event that at least one head is flipped. So if I'm thinking about what are the outcomes inside of E, those would be the outcomes where I see at least one H. So first three of my four outcomes that I've listed, heads, 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 tails, and tails, heads, those are all outcomes that's one head or more. So those are all the outcomes that are inside of E. F is the event that both of my flips are the same, so two matching flips. And if I look through my sample space, there's two different outcomes there where the flips match. Heads, heads, and tails, tails. Okay, let's do another example. So here, not a very exciting example again for an experiment. We're just rolling a standard six-sided die. So if we're thinking about for this experiment, we're going to see whatever number we roll. And what did we roll? Well, in our sample space, you have six possible things that you could observe. You could see a 1 or a 2 or a 3 or a 4 or a 5 or a 6. Those are the outcomes in the experiment. And now for the two events that we're interested in, E is the event that I roll an odd number. So if E is happening, that means you saw a 1 or a 3 or a 5. And if we're thinking about F, F is the event that my roll is larger than 3. Larger than 3 is greater than, not greater than or equals to. So when we say larger than 3, that's all the numbers bigger than 3, not including 3. So 4, 5, and 6. Those are my outcomes inside of F. Okay, so now let's think about these little other outcomes that we're thinking about. So I'm thinking about this event, roll an odd number larger than 3. So if that was my event, I'm rolling an odd number which is larger than 3. Well, I'd say, well, number one, I know what all the odd numbers are. It's 1, 3, and 5. And the only one larger than 3 is 5 itself. So if I were to list all the outcomes in that event, it would just be one outcome, just the single number 5. If we wanted to roll odd numbers or numbers that were larger than 3, and again, remember that the word or, we're using that in an inclusive sense. So odd numbers or larger than 3, or both, maybe odd numbers which are also larger than 3. So if we're thinking about that event, rolling a number that's odd or larger than 3, well, if you roll a number that's odd, you're rolling a 1 or a 3 or a 5. And if you're rolling a number that's larger than 3, you're rolling a 4 or a 5 or a 6. I've already got the 5 listed, so I just need to add the 4 and the 6 onto my list. And there we go. Those are all the outcomes where we're rolling an odd number or a number that's larger than 3 or both. D, the outcomes in the event, roll a number not larger than 3. So larger than 3 is 4, 5, and 6. The things that aren't larger than 3, it's 1, 2, and 3. And of course, if we're thinking about probably what you've been thinking about as I've been doing this example, these three things are definitely related to E and to F. If we're thinking about part B, that's asking us how many ways that E and F overlap, odd numbers which are larger than 3, that's E and F. If we're thinking about part C, we were looking for rolling an odd number or a number that's larger than 3, that's E or F. And for part D, when we were looking at that, we were looking at numbers that were not larger than 3. We were looking at the opposite of F. So in other words, we were thinking about not F. Probably no surprise here. I kind of gave it away a little bit earlier when I said we're going to be using and reusing some earlier set theory notation. So probably not a surprise that and, or, and not we're going to be using the same symbols that we used in set theory. The union, intersection, and complement. So if we're talking about one event or another or both happening, that's the union, exactly the same symbol as before with exactly the same meaning. Intersection would be E and F both occurring where the two events overlap, same meaning, same symbol as before. And for complement, same thing as before, it's the opposite of an event. Again, same meaning, same symbols as before. All right, let's do another example. So I have 4 events listed here for my experiment. My experiment is selecting a card at random and then just observing what kind of card I've observed. So I have A is that the card is a face card, B is that the card is a heart, C is that the card is an ace, and D is that the card is black. And now I want to take these things that I've written with set theory notation, A intersect B and all the rest, write it out in words. What exactly is this event referring to? And then let's ask ourselves what's inside that event. So if we're thinking about A and B, so these would be events where A is happening and B is happening. So in other words, the card is a face card and also is a heart. So in other words, we're thinking about hearts and face cards. So if we're thinking about who's inside A intersect B, you would say, well, number one, as far as face cards go, that would be jacks and kings and queens. And being a heart, well, that's just a heart. So there's 3 possibilities here. Maybe it's the jack of hearts, or it's the queen of hearts, or it's the king of hearts. And there we go. So we have 3 outcomes. For A union C, on the other hand, we're looking for cards that are face cards or heart, or aces rather. So A union C is you are a face card or you're an ace or both. In this case, you can't be both because if you're an ace, then you're not a face card. But if I were to say in words, what is this? Well, these would be the things that are face cards or aces. I'm not going to list them all, but I'm going to definitely count them. So if we're thinking about how many face cards we have in total, again, there's jacks, kings, and queens, and there's 4 of each. So that's 12 face cards in the deck. And as far as the aces go, again, there's 4 of those. So 12 face cards plus 4 more aces, there should be 16 outcomes. Let's think about C now. A complement intersect D complement. So it's A complement, not a face card, and at the same time D complement, not black. So not a face card and also not black. So 2 things we know. If it's not a face card, that means it needs to be an ace, 2, 3, 4, 5, 6, 7, 8, 9, or 10. That's basically all the ones that are not face cards. And that leaves us 10 numbers, each with 4 suits. So in total, we've got 40 cards that are not face cards. So 40 face cards in total, but of those face cards, we need them to be not black. In other words, we need them to be red. Of the 40 face cards, 20 of them are black and 20 of them are red. So if we're saying, well, how many should we have for this? How many should I have where you are not a face card and also not black? Then we're talking about cards that are ace 2, 3, 4, 5, 6, 7, 8, 9, 10, which are either hearts or diamonds. There's 20 cards in total, so in other words, 20 outcomes. And then finally, B union D intersected with C. So B union D, these would be hearts or black cards. So that would be hearts or clubs or spades. And at the same time, that needs to be an ace. So this is going to be cards which are aces. And for those aces, they either need to be inside of B or inside of D. They need to be either hearts or black. And we can easily count those because there's 4 aces. One is a heart, one is a club, one is a spade. So in total, there's 3 cards or 3 outcomes for this event.